there? All right. Hello, everyone. We're excited to introduce you to a new event where you get a chance to speak to a space professional. This event is being hosted by Indus Space in collaboration with AstroSTEM Labs. So welcome, everyone. We would like to acknowledge that the various indigenous lands that we reside on as an organization. This includes traditional lands of the Huron-Wendat, the Seneca, and the Mississauga of the Credit. We would like to thank our sponsors, Ontario Regional Malayali Association and Stonehaven Dentistry, for their support in our new initiative. And here's a little bit about your host today. So Indus Space Inc. is a social enterprise with headquarters in Mississauga, Ontario. Indus Space raises awareness specifically about space exploration and its connection to space science, technology, engineering, arts, and mathematics for youths, educators, and the general public. We provide programs and products for all grade levels. AstroSTEM Labs is an after-school STEM club based in Mississauga, Ontario. AstroSTEM Labs' mission is to make learning of this STEM subjects fun and exciting for children in grade 1 to 12. They conduct online coding, robotics, engineering, maths, science, and chess classes for kids across Canada. So follow us on our websites, Twitter, Facebook, LinkedIn, Instagram, and use hashtag CDN Space Talks to connect with us. Okay, so it's a reminder to everyone that this event is being recorded. So if you are not comfortable being recorded, then you can shut off your camera, and you will not be your video will not be available on the recording. If you do leave your video camera on, that means you consent to being recorded. Okay, so if you have any questions for the speaker today throughout any time, you can use this bit.ly link. It will also be in the Zoom chat. If you have another device, you can also scan this QR code and it will take you to our survey form where you can submit a question for the speaker. If you guys want to write down this right now, or I can just submit it later, that's up to you. Here are some basic ground rules. So everyone needs to listen closely, be respectful of all the other attendees and the speaker, ask questions when you're curious or confused. This could be on the Zoom chat or on the bit.ly link that will take you to the Google form. Keep your questions and comments short, and most importantly, have fun. And here are a reminder of the speakers that we have for the remainder of July. So we have Thomas Sears for July 14th, Dr. Hilding Nielsen for July 21st, and Dr. Allison Brady for July 28th. And here's our speaker for today, which is Dr. Bhairavi Shankar. She is a planetary scientist and a Canadian space ambassador. She received her PhD from Western University. She's passionate about bringing space programming to youth, especially girls and youth from BIPOC communities. Tonight, she will give us an overview of where space exploration has gone and where it's headed. Feel free to add any questions to the chat window or on the Google form. We will leave the last 15 minutes for questions today.
Okay, thank you, Prachi, and hi, everyone. I'm just about to put my timer on just so that I can remind myself about when I need to, slowly wrap up so I can hear all of your questions. I'm super excited. Of course, Prachi introduced who I am, but I'm here also on behalf of Indus Space. And so with AstroSTEM Labs Group, very excited to meet each and every one of you. Some of the names I do recognize, but some are very new faces to myself as well. We hope that through this next 8 weeks of talks, we inspire you to learn a little more about space exploration, learn of the different career paths and potential places you could also explore. There's a lot happening in the space sector. And so this is where our goal and hope is that we inspire you to tune into space topics a little more. So as Prachi mentioned, and as I had decided, my topic was just going to be very introductory. It is about just giving you all a sort of recap of where we've explored and where we're headed. So I will only like briefly touch on certain topics, but feel free to use the chat window if you have any specific questions on any of them, or if you even want to share how you feel or think about what these different topics are. So I'm gonna now just share my screen. Give me 1 second. Timer, no stopwatch. Okay. Give me a reaction, like a thumbs up or something, if you are soon seeing my screen. I'm assuming. Okay, I see thumbs up. Thank you, everyone. All right, this is good. So yes, all of that to summarize is exploring Earth and beyond. So I usually like to start my talk with a common question. So use the chat window, and Prachi, please tell me what responses come in. So question for you. Can you guess what is this? Where are we when I show you this picture? So use the chat window and type away your answers. Ooh. Ooh, there are many.
We're getting some planets and moons.
Is it just any specific planet in mind, or just like
Mars?
Mars. Okay, interesting. Okay, I'll give you another 30 seconds before we reveal what it is, but
we've got an Earth.
Okay, interesting. So while you're deciding, discussing, or maybe even writing it out, explain what it is about this picture that tells you that it's maybe Mars, or like what are you seeing that might indicate that it's whatever you think it is? Anything? No? Ah. All right.
So there's no water. So one of the things people are suggesting is because they do not see water.
Okay.
So that's why they think it's the moon.
Okay. All right. So drum roll again, all virtually. What it is Pluto. So this is a picture that was taken by a mission that flew by Pluto back in 2015. So maybe some of you were just born, or maybe some of you were like toddlers or something like that. But yeah, this is a picture. It's a black and white picture. So good observations that you weren't maybe seeing water as we know it, etc. But this is an image where, you know what, it was at the time something of interest. What are we seeing? It was interesting to note that Pluto has like a thin atmosphere. So if you're seeing these like waspy lines at the very top, that is indicating there's a bit of an atmosphere. This area out here, I'll be honest, there are some camps that think they're icy mountains, and there are some camps that think maybe they're clouds. So it's a very interesting, again, moment where the first picture comes in, and often the science community, the space scientists and engineers are trying to think, what are we seeing? And that begins the whole journey in discovering what has happened and what's the history for something as far away as Pluto. So I'll quickly change my slides, but basically that same mission gave us this view of a global view of Pluto when it was only a few thousand kilometers away. And again, it was a flyby. So it was just kind of like not landing or going very close, but it happened to see what Pluto looked like. There are lots of glaciers. There's a lot of areas that are nitrogen rich and things. So very exciting areas. And if it has come up on the topics, I can't see the chat window. Yes, Pluto is not a planet, but it is a dwarf planet, which means that it is still part of our solar system. And it's, if anything, telling us a little bit of what's happening in the very far corners of our solar system. Some of those pictures that were taken were actually zoomed in views of Pluto's surface. And if the picture on the left is just showing that there are craters. Again, show of hands or reactions on how many know what craters are. Turns out that is a very common process happening throughout our solar system. So Pluto also has it. One of the other neat things that we got to learn about this sort of part of the solar system was about Pluto's moon. So the picture on the left is of Charon. That is what is the largest moon. But the animation on the right is actually telling you Pluto's own moon system. So Charon is not the only moon. There are about 6 of them, or 5, yeah. And the other ones that are all looking oddly shaped, they're what are known as Kuiper belt objects. So they are like farther out from Pluto. And those are, again, small rocks, icy rocks that have now managed to come into Pluto's gravitational area, and which is why it's now one of Pluto's moons. But that is showing you just how interesting, again, the far corners of our solar system are. So I usually start off just to kind of highlight that, hey, when you look at our solar system, we now have a family portrait of pretty much every corner of our solar system that has been explored. This is showing you pretty much all of them. So if we had the time, we'd go into each of them in more detail, but safe to say we have explored everything right from the sun all the way out, even beyond Pluto, and looking at those Kuiper belt objects. Often how we do this is by sending a satellite, launching it up from Earth, giving it enough fuel and like boost to go out to any corner of this the solar system, looking at a planet. It has instruments. This is just it's an example view, but basically you would have what's known as a payload. It has a lot of instruments, and those instruments are used because it helps us in some ways. It can give us indication about topography, how high or low our surface is. It can tell us about, is there water in any of these rocks? Or is there any sort of, what is the atmosphere like? There are some planets that have a very thick atmosphere. There are some moons that have atmospheres too, right? So any of these sort of payloads really help us figure it out in a nutshell. So now I'm going to walk us through certain bodies in our solar system, and we'll start with our own moon. I love the moon personally. It is my favorite part of our solar system because it's not only the nearest thing to us, there's still so much that we can learn from our nearest neighbor. So what you're seeing is on the right half is just different types of data that have been collected by some of these instruments. And what it's doing is actually telling us, for example, temperatures. The very top ones are the orange looking maps. They are actually telling us what the temperatures are of the moon in the poles. So anything that looks blue to purple, coldest parts of our moon. And it's around the poles. And actually it's more on the southern poles. But then there are other parts that will get, like a lot of sunlight. And so the temperatures will get quite high. But the bottom one is actually another type of data collected by the same mission. The left one is, let me see if that is going to work. Yeah, it is going to orbit. So the left one, this blue area, is actually telling you topography. Anything that's light blues, dark blues, purples, deepest parts of the moon. And anything that is yellows or reds, highest parts of it. So again, we've learned a lot already from just looking at the moon. We see on Earth the near side, so we're only seeing one side of it. But guess what? The moon has another side, right? So it really tells us a bit more. And in fact, here's a side by side. Near side is the left picture. Far side is the right picture. And the colors again are telling you how high or low these features are. What is the one thing that everyone notices? Is there something very distinct in this pictures that you're seeing?
Craters.
Craters, thank you. Yes, every round thing in this picture, either side of it, is a crater formed because the space rock came and hit onto the moon's surface. And guess what? Because the moon doesn't have an atmosphere, everything is recorded. So, largest crater in our solar system, South Pole Aitken Basin. So you see this sort of bluish thing on the right picture? That is one edge of South Pole Aitken Basin, largest impact feature in our solar system. End to end, they estimate it goes about 2,100 kilometers. So think about what is 2,100 kilometers on Earth. If you're in Toronto or Mississauga, where is 2,100 kilometers? I feel like that's like Alberta. I don't know, but maybe. So it could be, there's a feature that's that large. So the moon is, again, a really neat place that we can always go back and explore because we'll always learn new things. But moving along in our journey, Mercury. So one of the things that we have learned even from the moon, but also on Mercury, is that Mercury, even if it's the closest to the sun, there are areas on Mercury's poles that will never see sunlight. And so anything that looks yellow in this sort of middle picture is showing you areas where they think that there is water. So that was taken from observations from Earth. They had a telescope, they looked at Mercury, they're like, oh, I think there's water here. Those are all the yellow spots. But guess what? We sent a mission called Messenger. And that's why you're seeing a sort of weirdly looking colored Mercury. The colors are telling you what surfaces are old, what surfaces are young, and actually what are these surfaces even made up of? What's the chemistry of it? And so Mercury has very, there are some areas that are very iron rich, but then there are some areas that are very sulfur rich. So that's interesting. But the neatest thing that they found was, remember all those polar areas where they thought there was water? The Messenger mission had an instrument that could look at those areas just orbiting. They looked at it, and anything that looks red, guess what? Those are known areas where water is trapped in the rocks. So not bad. For us looking at it from Earth, they were able to predict some areas, and the instrument then went and said, hey, guess what? There's a lot more areas. And this is all happening on Mercury, closest planet to the sun. Amia, I'm seeing your hand up. Do you want to type your question on the chat window? Because it'll be a while maybe before we can get to your question. But yeah, if anyone has questions, use the chat window. Type away in there. Okay, so next, moving along. What's that?
Actually, I'm small, so I don't know how to type words.
Okay, you know what? So hang on till we're wrapped up with the talk, and then I'll come to you and ask you to ask your question. Okay, so hang tight. Okay. Yeah, thank you. So Venus, how many have seen Venus in the night sky? Maybe you have looked up at the night sky and there's a really bright looking thing. You're like, what is that? That is quite likely Venus. It's a very easy to spot feature if you're looking up in the night sky. So Venus, what we know already from observations are it's very thick atmosphere, 400 kilometers of atmosphere, all rich in carbon dioxide, which is why it is known as a greenhouse gas. And then that means that the surfaces of Venus, very hot, like super, super hot, hotter than your oven can get, right? And so when you have a planet covered in atmosphere, it's a bit hard to see what's underneath it, right? But there was a mission that went out in the early 1990s, so well before your time. Maybe your parents will remember this. There was a mission called Magellan. It went to explore Venus, and it had in there, its instrument was what's called a radar instrument, which meant that it could send radio waves through the atmosphere and figure out what the surface looked like. And guess what? This orangeness is what, it's not like true color, but what it's telling you is that Venus is so distinct. You don't see continents, but Venus has areas that look like craters and other areas that have a lot of volcanic features. So like lava flows and things like that. And Venus has tectonic, so movement of one plate, and not many plates, but that movement had caused tensions. And so the cracks, the crust cracked in some places, it stretched in other places. All of that happened, and they could figure that out because they sent this instrument. But guess what? This mission was 30 years old. easily. And we're now trying to figure out, well, let's look at it a bit more. What's happening in that atmosphere? Is there anything else that we should know? Can life survive in that atmosphere? It's still a valid question. And guess what? Very excited that in the last month, so back in May or early June, there was an announcement. We're going to send 2 more missions to Venus in about 10 years. So right by when you are probably in college or like post-secondary, or maybe even graduated from post-secondary, guess what? There are missions that are happening that you might be interested in participating in. One of them is called Da Vinci, kind of like Leonardo da Vinci. It is gonna go and investigate the atmosphere. But the other one is called Veritas, and it is gonna explore the surface, trying to figure out how, where are the sort of rocky areas? What is the soil made up of? Things like that. So there are 2 different missions with 2 different purposes, all headed to Venus. So stay tuned. So now we move to, I think what I will guess is everyone's favorite planet to look at. This is a portrait of Mars and all the missions that have ever been attempted to go to Mars. But this is, you know what, an old picture because it's not including the updates that we have in the last few years. Namely, India sent an orbiter, Mangalyaan, around to Mars. That happened. And then in this last year, I mean, even in this like last 7 months, we have the United Arab Emirates have sent one called the Hope mission. That's also orbiting. It was the first time they did that. China has sent its rover and an orbiter. They've done that. And then, of course, you have all probably heard of Perseverance, right? That is the most recent rover that is exploring Mars. So this is a sort of a picture of how Perseverance is. How many have heard of Curiosity? Show of hands? Yeah, okay. So similar to Curiosity, but bigger. Many more instruments, many more cameras. And so it's almost like you're getting a very high level upgraded version of Curiosity that will technically last a lot longer. So one of the neat things, there are a couple of neat things with Perseverance. One of the neat things is this instrument called MOXIE. So it's sort of written out over here. MOXIE has the key of that instrument is to sort of take in the carbon dioxide from the atmosphere of Mars and convert it to oxygen. Why do we want to do that? Who can use the chat window? Tell us why we want to do changing up carbon dioxide into oxygen. Anything?
So we can actually breathe there.
Exactly. The idea is we want to send astronauts. We want to, you know, go and explore for a lot longer than maybe rovers could do. And so in doing that, this will really help us understand how humans can go and explore Mars and stay safe. So guess what? This instrument is a test run right now on Perseverance. Sherlock, there's so many cool instruments on Perseverance. I think it'll be its own talk. And I'm hoping later on on July 28th, when we have our guest speaker, she might touch a little bit on that, but certainly she's looking at how Earth and Mars are, you know, compared or are alike. And why do we study on Earth to know more about Mars? Anywho, moving along. These are some of the early pictures. I only selected one, but really in the last about 5 months, Perseverance has taken amazing photos. I would recommend everyone just do a Google search and go onto their website and start exploring all the different surfaces, pictures, videos that Perseverance has managed to take. But in here, you might see something, another thing in here. That was the newest thing in exploring Mars, right? So we have over here a helicopter, a drone. Some people call it a drone, but this was the first test run of sending a helicopter. It has never been done outside of Earth before this. So they decided, let's just send it. Let's see how easy or not it is to fly a helicopter through Mars's atmosphere and go and start exploring. There are a couple of reasons why we wanted to try this. For one, imagine if you have sent a rover to Mars, you as humans are also exploring Mars. You happen to be at a crater where, you know what, the slopes at the edges are so steep. A rover can't drive on it. A human, it wouldn't be safe. So this is where a helicopter comes in handy. It can kind of go and look at all of those areas that are not visible to us at eye level, and it can go and explore, report back to the main central like base station, and then say, hey, this is something interesting. So this is again where innovation is being pushed forward just so that it can help us down the road. So very excited to say helicopter has worked. They wanted to see how it would do for 30 days. Mars's temperatures can get pretty cold. Mars's atmosphere, a lot thinner than on Earth. So they were just literally saying, let's test this out. And guess what? It's been doing so well that they have now managed to do 9 different runs and trials. And they have been able to like push the boundaries. Again, they want to see how long this thing will last. And so far it's doing really well. So that's a lot about Perseverance, but I'll move it along. These are some of the photos that they have taken. This is, imagine a camera on Perseverance is looking down on its own self. It's able to spot 2 of the wheels. So this right here is 1 wheel. That's another wheel. There are 6 wheels in total. And look at all the little tread tracks that it has made as it is just like driven around. It's so cool that we can see this from, you know, from another planet. I'm hoping this is working. Yes, it is working. This was a video capture. So imagine Perseverance is looking out at the helicopter Ingenuity, and it's taking a video of that helicopter doing a test run. And in this test run, this was back in April, first one that Ingenuity had done. It was just seeing, can I go up? I will just scout around just where I am and I'll come back down. That was the test, and it did it really well. So this is the video that Perseverance took and then streamed it back to Earth. And so now we can actually also see it. So cool. I think like it's very neat to see how rovers are kind of pushing the boundaries. So before I move away from Mars, I do want to mention, you can figure out and you can track where Perseverance is through NASA's website. So if you just do a regular search of NASA, where is Perseverance? This is a website that shows up and you can follow along. This is just a screenshot, but on the actual website, you can zoom into each of these areas and you'll now see, this was from today's screenshot. So Perseverance, as of today, has already driven about 1.4 kilometers from where it landed. It landed inside a crater called Jezero crater. And it's just, the purpose is just to go and explore what's happening in the crater. What can it tell us about the geology of it? What's the history, any water that was flowing, etc. And so that's where Perseverance is here. And Ingenuity is actually not next to it. It's actually gone and explored a little of its own, right? So this is showing you where they are right now. But I highly recommend if you want to go and see where they are. I mentioned, so there were many missions that happened in this whole year, and this is actually from the Chinese rover, Zhuyong, I believe is the name, or Zhurong. And this is the first picture it took before it even got off its own lander. So you can see it has reached a different area on Mars. And this is one of those pictures it managed to send. So it's like as if we're actually all over there and we're able to see how Mars is looking. So again, I had that portrait, where have we gone? This is actually a map. So imagine if you had like a Google Maps and you wanted to see where all have Mars missions been, rovers been, anything that looks is written in white ink or font means that they successfully landed. Mars 2020 is what Perseverance is. So that's the official name of the mission, but that's where Perseverance landed. And the Chinese one landed somewhere in that general region, but it's in a totally different area in general. So you may wonder, why are we sending so many missions to Moon, Mars, etc.? Each mission goes and explores a new area. So it's giving us a little bit more of information. Okay, so in the time that we have, I'm going to zip past our inner planets and go more outward. So next we have the asteroid belt. So this is a little, like, asteroid belt spans several, it's quite a thick area between Mars and Jupiter. But one of the things that they have discovered is that there are certain asteroids that are really water rich. So you're seeing Ceres is one, Vesta is another, and all the reds and the blues are just telling you how much percentage of water is in these rocks. It's quite high. And if you compare like it to Earth, Earth is actually a lot less. Earth, we may be filled with 75% water, but for a planet our size or where we are in the solar system, we don't have as much water. So this is where we look at asteroids to learn more about how does water, get trapped, and what does that mean? Okay, one of my most exciting things has been this mission that has actually gone and explored a near Earth asteroid. So it's an asteroid that is sort of closer to Earth. It's not going to hit anytime soon, but this was one where they sent a mission and they wanted to see what can this asteroid tell us about the solar system. So the mission is called OSIRIS-REx. I don't know if anyone has heard about that. The asteroid is called Bennu, Bennu. And I'm now going to play a video that'll show you how, once they sent the mission, as it reached closer to the asteroid, there were a few things they wanted to do. It is orbiting the asteroid, but they wanted to go and grab a sample, put it back in its little canister, and then send that sample back to Earth. So this video is going to show you how they decided where to actually go and grab that sample. I want you to use the chat window and tell me, how does this asteroid look to you? What is unique or what's familiar? Anything? You're just mesmerized by this video?
Someone's asking if these are craters.
Good question. So craters. Some areas are craters, but they're very mild craters. So you, unlike the ones that I've shown you photos of before, these are like little bumps. Like, is it a crater? Isn't it a crater? That's the neat thing with this asteroid. It's so small and it's so light. You're like, how is gravity even holding this together? Because it's very small. But these 4 areas were the sort of final locations where they thought, okay, we're going to go and, grab a sample from one of these 4. They ended up choosing Nightingale. So the one at the top left, wherever that's pointed to, that's where they went and got the sample. I will mention, this is a very important mission for us in Canada because we sent instruments on this that helped the team figure out how bumpy or not this asteroid was. So it's called OLA, laser altimeter. And that was the one that helped us figure out, oh my gosh, this is so rubbly. There are craters in some areas, there are rocks in others, boulders in other places. And this really helped the team figure out, okay, we want to go and grab a sample at a spot where it's not going to bump our instruments. We don't want to lose our spacecraft, right? Like, we have to send it back to Earth. So the OLA instrument that was built right here by a company that is in the GTA helped us figure it out, and with a partnership with Space Agency and I think York University. So very exciting. But now my next video is actually going to be, this is a GIF, so an animated screens that were put together when the instrument was actually now picking up the samples. So check it out. So it's running a few times till I move on to the next screen, but basically there was it was known as a tag and go grab. So it was like a touch and go process where this arm stuck itself out. It went close to the surface, and as it reached there, it then stayed for 6 seconds. Whatever it could collect in 6 seconds, it grabbed it, put it into the canister, and guess what? These mission samples are now headed back to Earth. So in about 2 years or so, we'll hear it in the news that these samples have come, and then every country and every team is going to be able to investigate a little bit more of these samples. It'll tell us a little bit about our early solar system. So very exciting times. We have a lot to look forward to from this mission. Okay, I'm keeping an eye on the time, and I have about 5 more minutes. So I am going to quickly go through the rest of our planets. Jupiter, there is a current mission called Juno, just looking at the atmospheres of Jupiter. So again, if you do a Google search of Juno mission, you will start to see a lot of pictures, very pretty pictures, but also a lot of data. This is where, because we're collecting so much data, we're putting the call out to everyone who is a citizen scientist. So if you want to investigate any of this, they explain how to do it, and then you can help the teams understand what's happening in Jupiter and things like that. So Jupiter has many moons, but these are the 4 big main ones. And again, we have had missions that have helped us discover how icy these moons are, how volcanic some of the moons are, and really how much influence Jupiter has with any of these areas. So much. Saturn, another favorite planet. Saturn, there was a mission called Cassini. It went and explored not just Saturn, learned about the rings, but also the moons. Enceladus is one of the moons. You can see just how icy it is, but imagine those iciness and the tectonics are making such amazing features on the surface. So there's a lot of ocean that they believe is underneath all of this ice, and there's a lot of fissures. So imagine when you have some steam that releases, how it comes up through the cracks. That's what you're seeing even in this sort of top image. It's like, that's happening even on Saturn's moons. Saturn has another main moon called Titan. And this is where, again, they sent a little, they dropped a probe. The probe only lasted for a few minutes, but in that time, they were able to take photos of the lakes on Titan. These lakes are very methane rich, so not like water, but they're flowing. It's not like it's rocky or it's like frozen, it's flowing. So this is one of the neat things that we are learning from Titan and its presence next to Saturn. It's very cool. I've been talking about our solar system, but really I want to bring it back to Earth. This is what? An impact crater right here on Earth. This is, if you have heard of or plan on visiting the Grand Canyon in Arizona, I will highly recommend go and visit this place as well. It's not too far. And it'll be the first place where you can see how big and how deep a crater can get. And this is one of the simplest, smallest craters when you look at that. But it's known as Barringer Crater, and it's in Arizona. So I'm going to end off with space station. Let's not forget, we've gone and explored the solar system, but really, if we want to know how humans can survive in space, there's nothing better than the space station. It gives us an opportunity to test and have experiments, understand how to grow food in space, understand how to do like mechanical work, fixing up things when you're up in space and you don't have as much gravity. And so the space station has been there for 20 plus years. And guess what? There are more in coming up. Canadian astronauts are going to be part of what's happening very soon. In the next few years, we're actually going to be sending an ISS 2.0 around the moon. So again, by the time you are all in either high school or just beyond, this will be some of the exciting things that are coming up. We want to send a space station, wanted to orbit the moon, and essentially that becomes one part of a broader goal. We want to land on the moon, set up a base, things like that. And what? Do you recognize this little feature over here? I'm hoping you do. This is well, we know it as Canadarm2 on the space station. We've been invited to make Canadarm3 for this version. So it's known as the Lunar Gateway mission. There's a lot that is happening in the next many years. So stay tuned. If anything like robotics or humans in space or any of those aspects are of interest to you, there's tons happening. And again, it's not just one country doing it. There are many countries doing it. So there's always a little bit more that you can tune into. So I'm going to end off by asking another quiz similar to the first one. So who wants to guess, and again, use your chat window on what is this location? Type away in your chat window. I guess questions are, is it the same planet? Or do you think it's more than one planet? So while you're doing that.
We have some guesses, and it's Earth so far.
Okay, so everyone thinks all three pictures are Earth? Okay, interesting.
We've got one that thinks, or two people that think it's, or more people that think it's more than one planet now. Someone's suggesting Ganymede. So it's another one suggesting the Pluto.
Okay.
And Mercury.
And
Moon. We're getting more guesses now.
Okay, so I think I will reveal what these are. So remember the order of them. There's a gray in the sides, a color picture in the middle. This is what it is. So the leftmost was Mars, the middle was Earth, and the rightmost was Titan, which was what? Saturn's moon. So what the takeaway from all of this is, you can use different instruments to understand anything about a surface. But you can also notice there are some common things, right? Like in this three pictures, you're seeing a bit of a channel that's going through. On Mars, it could have been past water flow that is now just left behind a dry channel. On Earth, this is a rotated picture, so it's upside down, but this is of the River Nile. How many have heard of the Nile River? It's out in Africa, right? So that, again, a river that's going through and cutting through the rocks. And on the right is Titan's lakes. Again, these are channel features of lakes that are rich in methane. So that is the common thing, in that you can have this happen anywhere in the solar system. And so with that, I will end off the talk and just say, ask you, where are you going to explore next? And I hope this has given you a sort of introduction into how space exploration is not just from the past, it's happening actively now. And there's a lot to look forward to in the future. I missed out mentioning that there is also the James Webb Telescope that's going to launch in like later this year. They have finally decided on a date. So that's going to go and look out towards the parts of the universe that'll help us understand more about galaxies and things. So I just focus more on planets and solar system exploration, but that is one side of so many things. So I hope you have enjoyed that. I will stop sharing my screen just so that we can see if there are questions. And I know I will actually start us off with Ameya because she had her hand up the longest. So I will ask Ameya, do you want to ask your question now?
Yes, actually, Titan has very acidic rain, and Titan is almost the same as Earth.
In size? Yeah, that's true.
Yeah, and also Titan, the lakes, it don't really have water. It has acidic water, which is a little bit acidic and stinky.
It's stinky. I know methane is quite stinky. If you've been around cows or like a greenhouse area, that's what it is. Even on Titan, that's true. That's very true. So you might have to think about how to have like masks that help prevent that smell from coming, right?
Yes.
But thanks for letting me know about that. That's very true. Okay, I see a hand up. Ayush, go ahead.
Since I'm more interested in the technical part of space, what rocket will be used?
Oh, good question.
Is it Atlas 5?
What's that?
Is it Atlas 5?
That is one of them. I think they are testing a few out, but Atlas 5 seems to be the one that's ready to be tested, right? And so that's
LS5 is everywhere for the long missions, but I'm asking what's the one that's going to be used for, or maybe a Delta V?
it's I think they're all in testing phases, so they're trying to do many more tests just to
Yeah,
see
but
what it can handle.
what's the size of this thing?
The size as in like the height of it or the weight of it?
Like the weight.
Oh, it would easily be several million tons, I would think.
The weight of the thing,
Of the Atlas V?
not the Atlas 5, the cargo.
Oh, the cargo. It would be a very small part of it. Very good question. So a lot of the weight in that entire package would be more for the fuel and the thing that'll help boost it up. But the actual payload may be a few 100 kilograms. Depends on how much room there is, right?
And
So
an Atlas 5, I think the Atlas 5 should be the best option for it.
yeah, that's again one of several. So I think they will be it'll be interesting to see where does the Atlas V, like what cargo it can hold and where can it actually get it to. So those would be some of the questions that they'll.
Okay, that's all.
Yeah.
Okay.
Okay.
One of our other questions is that why did the arm only collect a sample for only 6 seconds? And was it to prevent contamination?
Great question. A bit of that, but also, you know what, they didn't. I'll be honest, going in before the mission reached Bennu in general, they weren't really sure of how much gravity they had to deal with from the asteroid, right? So they didn't want it to get too disturbed that it eventually, like, it pulled the sort of spacecraft closer. They wanted to just be able to touch enough and have enough time to then launch itself back away from the asteroid, just so that it could eventually get back in orbit and then make its way back. So that 6 seconds timing was like really to be as quick as you could in getting the samples, but also ensuring that you weren't there for too long. Otherwise you'd be like, you'd be close by and you'd be losing some of that fuel, right? Like that you wanted to get back away from. But in that 6 seconds, I will say they collected so much more than they anticipated. They had some trouble closing the lid of it. That's how much it collected. So it was not a bad thing to try just for 6 seconds, but yeah. Thanks for that question.
Somebody's asking, how do different moons come to exist?
How did different moons come to exist? I can use our moon as an example. At least with our moon, what happened was there was very early in Earth's history, right? So Earth is cooling down, it's starting to get its crust, but it was still like in its baby years, basically. At that point, there happened to be a space rock that was about the size of Mars. So again, very early days. And so that happened to come super close to the moon, that it had a gentle impact, right? We all know about impact craters and how that happens. And that's how the moon is also thought to have formed. It was a very gentle one. It wasn't like a head-on collision, but in that process, it managed to separate out part of early Earth's layers, and that eventually cooled down, and it was close enough to Earth that Earth's gravity still held it close by. And so as that then started to cool, it started to form our moon. So often moons tend to be formed either that way or they're grabbed from far away. So imagine a space rock floating in space happens to come super close to a planet whose gravity can tug it in, like pull it in. And that's how other moons have also formed. So Pluto, that example where I showed you all the different ones orbiting, outside of Charon, the other moons are likely things that were just too close to Pluto and Pluto just brought it into its own system, but it's not from originally like a collision thing. So hope that answered that question.
I think Adwait might have a question for you.
I see Adwait's hand like going actively. Okay, did you have a question for us? No? Were you just stretching? Okay, that's fine. Okay.
Another is, how old is the sun?
Okay. So our sun is right now a middle-aged star. And by that, I mean, it's about 5 and a bit billion years old. They expect our sun to last in total age. It'll last about 10 billion years, which is why I said our sun is middle-aged. So it's not quite young, it's not quite old, somewhere in the middle. And so, yeah, we have a lot of time before we have to think about what's happening to the sun. So not in our generation, for sure. But yeah.
Another question is it true that space is never ending? If so, have any astronauts explored it yet?
Space is expanding. I don't know if that's the same way of phrasing it as never ending. It is expanding. And so, yes, there are studies and observations happening just to figure out what rate it's expanding. But astronauts, honestly, the farthest we've been is to the moon. And even then, that was about 52 years ago, because July 20th is the anniversary. And so we want to send astronauts further out. But right now, the most we've gone is the space station. So I think we have a lot of work ahead of us. But I will say it's not just easy to send someone out into space. You have to think about a lot of things, namely safety, right? So how do you ensure the astronauts are safe while they're going and exploring? And that's where a lot of research happens. Okay. I feel like, oh, I'm seeing so many messages on the chat. So
yes.
I'll have to read this later.
So one of them is asking, how many moons does Jupiter have?
Last I heard, or I read somewhere, it was about 72. It could have gone up. Every month or so, they seem to find more moons. And this is the thing, Jupiter, after the sun, Jupiter is the next biggest object in our solar system. So imagine its gravity is so strong that it is able to pull and keep in its neighborhood all of these different moons. We only think, we mention about the 4 because those 4 are the ones that Galileo saw through his telescope. But oh, someone says 79. Yeah, so the number keeps increasing. So it's roughly around there. And Saturn, I believe, in comparison, is about 80 moons. So they're all moon lovers, I think. Okay, Arman, I see your hand up. Question?
So basically, I have a comment.
Okay.
All the planets could fit inside Jupiter.
Yeah, I would think so.
Yeah.
Oh, thanks, Arohi. Yes, 86 moons. Oh, I'm seeing how old is Earth? So Earth is about like 4.2 to 4.5 billion years old. Not that young compared to the sun. I said sun was about 5-ish billion years, and so Earth is just soon after. Yeah, so it is pretty old. The only thing is that we don't have any leftover rocks from that early Earth because of what? We have plate tectonics, right? So the whole process of plates moving towards each other, moving away from each other, just meant that some of those rocks have been eaten away is the wrong word, but I think it helps describe what's happening. So it's sort of removed from record. And so we don't have any, unless you go and look for minerals or indicators of something that old. I think the oldest they've detected is maybe 3.8. There's nothing older on Earth that still exists now, which is why space exploration also happens. We look at other planets, other moons, to help us understand what happened on our own planet. So it's sort of a collective effort. I'm also recognizing that we have about 3 minutes left. So I am going to take one last question. But if you have more, just keep writing away. I'll find a way, and then you can always reach out to me. We'll figure out, yeah, we can share our emails, or if you're on social media, you can find me there. Is there a way, Yusuf's question, is there a way scientists are finding ways to allow space instruments to reach their destination faster? Oh, I don't know. space instruments. You know what? I don't know if it's able to reach destinations faster, but I will say one of the things that's on Perseverance right now is a navigation system that is helping it figure out where to go. So in some ways that is saving time because the rover doesn't have to wait for mission control to send those instructions and then read it and then do it. It can kind of figure itself out, knowing how it should interpret what it's looking at. And so because of that, it is sort of saving time, but I don't know if it is helping it reach faster. So good question, but I have to say I'll have to think about it. But in the meanwhile, thanks, Prachi, you've pulled up a poll. So if everyone can go and just fill in, we're looking for feedback. Yeah, it is going to be, there are just 3 questions, but we'd love to hear what you thought. And I really hope all of you will be joining us next week when we have our next speaker, but I'll let Prachi do the wrap up.
Okay. Just give me a second. All right, so thank you everyone for attending today. So next week we have Thomas Sears and his talk is about space jams. So if that seems interesting, join us. On July 21st, we have Dr. Hilding Nielsen. On July 28th, we have Dr. Allison Brady. And if you're interested in any of the talks, sign up on our Eventbrite or join the Zoom link that is sent to you by Astro STEM Labs. And if you have any more questions, let us know on the Zoom chat. But other than that, see you next week and have a good evening.
Yeah, thank you everyone for joining. Very exciting to have met you virtually, but we'll see you next week.
Bye.
Bye.
Bye. Bye.
Bye.
Bye.